Well, our task is to complete the square to find the zeros of f of x equals 2x squared plus 16x plus 10. But before we do that, let's talk about completing the square in general. So, when we're done, if we're going to complete the square for our purposes, then we want this form. Some linear expression squared plus a constant, positive or negative. And let's put some linear expression in here. How about x plus a? There, that's the form we're shooting for. So, next step, let's just consider what x plus a looks like when it's squared. And we'll write it as 2 factors, then we'll expand it using the FOIL method. So the product of x and x is x squared, the product of a times a is a squared plus, and now this product ax plus this product ax added together gives us 2ax. So anytime we square a linear expression, this is the form we're going to get if the coefficient on x is 1. And notice this, if we take half of the coefficient on x and square it, we get a squared, and that will always be the case. Now, consider this, y equals x squared plus 2x. What would we have to add to this to have a perfect square? Well, let's see, half of 2 is 1. If I add 1 here, I'll have a perfect square, but wait a minute, we've got an issue. We can't just arbitrarily add 1 without violating that equal sign, so I better subtract 1 also. Now we've simply added 0, and the equal sign remains intact, not violated. So these first 3 terms will factor, giving us a perfect square, and with our constant friend, -1. Let's try it again. Y equals x squared plus 10x. What would we have to add to this to get a perfect square? Well, of course, we have to add 0. That's the only thing we can add, but 0 in the form of our choice. Half of 10 is 5. If we square 5, we get 25. But the only thing we can add without violating the equal sign is 0, so we'll subtract 25 also. And now we can rewrite this in terms of a perfect square and a constant. And this is going to be x plus 5 quantity squared. So we have completed the square again. Well, now to the task at hand. We've got to complete the square to find the zeros of f of x equals 2x squared plus 16x plus 10. And right now we have a problem. The coefficient on x squared is not 1, it's 2. We've got to wrestle this thing to the ground. So here's our strategy. We'll factor a 2 out of the first 2 terms, close parentheses, put our plus 10 here. Now, we can complete the square relative to this expression, x squared plus 8x. So half of 8 is 4. And if we square 4, we get 16. So I'll add 0 to this thing in the form of plus 16 minus 16. Now we have another problem. What do we do about this negative 16? Well, the distributive property tells us that we can remove anything from between the parentheses as long as we multiply it times whatever the factor is outside the parentheses. So that factor happens to be 2, so I can remove that negative 16 if I multiply it times or by 2. And 2 times negative 16 is negative 32. So, now we have the coefficient 2, and this now is a perfect square, this expression, so we can factor that and we get x plus 4, and that's quantity squared. And then 10 minus 32 is minus 22. Now, to find the zeros of that thing, what we have to do is set f of x equal to 0. So f of x equals 0. That is 2 times the quantity, since f of x equals this, x plus 4 quantity squared minus 22 equals 0. Well, we'll add 22 to both sides, so 2 times x plus 4 quantity squared equals 22. Dividing through by 2, we get x plus 4 quantity squared equals 11. So now, by the square root property, we can take the square root of both sides, and what we get is, by the square root property, what we get is a plus or minus root 11. And finally, to find the zeros, we'll subtract 4 from both sides, so x equals minus 4 plus or minus root 11. So the corresponding ordered pairs for these zeros are negative 4 minus root 11, 0, and negative 4 plus root 11, 0, and we are done.